Okay, so on homework, we looked specifically at problems. Can y'all, when you watch this video, can y'all zoom in if you need to see it a little bit? Trying to pull in the problems. Okay, that's better. You can see that. So what we're going to be doing today is we're going to be comparing rational and irrational. So we're not learning anything new. We're now using what we know about them. And so I'm going to model for you the easiest ways to think these out and prove your answers. Does that make sense? Okay, so look at the first. Okay, so the first is 13 through 16. They're very similar to what you've done before. You need to take the actual square root and place it on the number line where it belongs. So if I've got square root of 5, that's rational or irrational? Irrational, because it's not perfect. I'm going to estimate it or use my calculator. So let's go ahead and model on our calculator what we do to get the square root, because you're going to be in algebra and not 8th grade. So I'm modeling it for you right now on your calculator. You basically turn the calculator on and you find the square root button, which is the x squared right here. Okay? Now, when you find that x squared button, notice that it is in blue, right? Any of the light blue keys, you have to hit second first, then the light blue key. If you need a light green key, you hit the green key first. The ones on top, you just hit the button. So to access that light blue radical sign, you hit second x squared and you'll see it flashing. So then all you do is put 5 in and you get 2.23. Obviously it keeps going and it doesn't repeat, but I only need probably to the hundredths or thousandths place to mark it on my graph. So 2.23, I write that down and then I know where to place it. It's going to be about here on my number line. Okay, so now let's do square root of 14 in your calculator. Second x squared, 14, enter. And what do you get? 3.74. So where does this go? It goes closer to the 4, and I just put the 14 in. When you're marking it on a number line, you need to make sure that you use what they originally give you, not what you reduced it to. So if you notice on my answer, I am putting square root of 14. I'm not putting 3.74. Okay? What is square root of 6? 2.449, and then it's negative. So now I know that it's about 2.5, right? So I'm going to place negative 6 square root where it belongs. In the middle between negative 2 and negative 3. And then what about square root of 13? 3. Square root of 13. 0.60. All right, so that's going to go a little past the negative 3. So I'm going to place it right here. So by using the calculator, I can compare my radicals and place them on whole numbers on a number line. It becomes even clearer when we compare numbers like numbers 17 through 24. And this is what you're going to be focusing on today. How did I place those numbers on the 4 previous problems? What did I do? How? What did I use to help me? What did I do? Look at them. I changed them all to what? Decimals. Because I know money. You know money. So if I'm comparing decimals, it's much easier to pick which one's greater or which one's smaller. So when you look at 17 through 24, that's what they're asking you to do. Y'all remember the alligator, right? Alligator chomp chomp, it's gonna eat the bigger amount. Greater than, less than. Do not laugh because I still ask myself, which one's bigger? Okay, it eats this one. I still say that because it makes me not get the answer wrong, and I'm all about getting the answers right. So let's look at the first one, 17. 1.7 is the decimal they give you, but they give you square root of 3. So go into your calculator and give me the decimal for square root of 3. $1.732. Now, I'm going to give you a clue. I would always put 3 decimal places, okay? Because if I'm comparing, look at this. If I don't put 3 and 2, they look like they're what? Equal, but they're not. Because if I add zeros to this, which one's bigger? 700 or 732? 732. So this is bigger, square root of 3. See how that works? So look at 18. I have square root of 6. What is that as a decimal? 2.440? 449, because remember we won 3 places. 2.5 is the same as 2.5. That's a benchmark fraction. So now which one's larger? 2.5. And you can go ahead and put your symbol. It eats the larger one. Now be careful, because on a test, they want you to compare the ones that they give you, not the simplification. All right, so let's do these. 4 and 2/5, what is it? You take it on your calculator, 2 divided by 5. Okay, so you got 4.4. Now, square root of 19, what is it in your calculator using the radical? 4.358. Add some zeros here. Which one's bigger, 400 or 358? 400 is. I gotta watch where I place this because I'm trying to stay on the screen, but I want to get it bigger for y'all. Okay, so now look at this one. 4.8 repeating, so that's the same as this, right? Square root of 24. What is it? 4.898. That makes a big difference. Which one's bigger? The 898. So the square root of 24 is bigger. They can be that close. So it's important that you make sure that you're putting 3 decimal places to compare. All right, 6 and 1/6. Divide 1/6, and what do you get? Guys, this is supposed to be quick. You're not going to have time on a test to take this long to divide a fraction in your calculator. What is 1 divided by 6? What is it? 6.166? Okay, now what is the square root of 38? 6.164. So which one's larger, the 166 or the 164? 166. Come on, we're counting. All right, last 2. Square root of 55. It's on your, should be on your paper. Square root of 55, what is it? 7.416, and then 7.4222. So which one's larger? 7.42. All right, so I'm gonna move from there. The last 2, the answers were equal and greater than for the last 2. So now I'm gonna go ahead and hand out your Eureka packet for today, because we are gonna be comparing everything that we have learned in the past couple of days. And I'm leaving it on video because I want you to see how I model how to answer it. So here they come. You can staple it together. Okay, so on your test tomorrow and as you're working through this year, you are going to be required to compare irrational and rational amounts. And so you have to use your knowledge of what you know already to help you compare them. So if we look at the first challenge, I'm going to do the first two as examples so that it goes onto your video. And then you're going to work with your partners to actually compare them. So look at the first one. This is what we call an MP3. Next week, we're going to dig into what MP3s are and how to write them. The question asks, Rodney thinks that the cube root of 64 is greater than 17/4. Sam thinks 17/4 is greater. Who is right and why? Can you tell me why you think this is called an MP3? What do you think MP3 means? What are you doing in that problem? What is that question asking you to do? See who is correct. You are grading people on MP3s. You are analyzing their work and determining did what they do in the math, was it right or was it wrong, and fixing it. So we're going to really dig deep in how to write those as we go along through the year. Okay? Because that is a huge, huge type of problem that you see on the end of course. All right, so when I'm modeling this, I am going to split up my work because I want to show all of my work. Now, I know that the cube root of 64 is perfect. It is what? And for you guys, you have a list in your notebook that can help you. It's 4 because 4 times 4 times 4 is 64. Then I know that 17 divided by 4, when I do that in my calculator, is what? One person answered. 4.25. So now I have two numbers that I can compare. Which one is greater? 4.25. Notice that I'm putting my greater than, less than symbol. It is going to eat the fraction because that was what was original in the problem. So, who is right? Sam is correct. Why? He is correct because the cube root of 64 is 4 and the decimal for 17/4 is 4.25, which is a larger amount. How many sentences did I write? 2. And I answered the question. It should always be between 2 to 3 sentences and you get it done. Now, the second example that I'm showing you is a lot different because it doesn't ask you to analyze work. It just asks you to compare. So if we look at the second one, it says which number is smaller. And I probably want to underline if they want me to look for smaller or larger because I need a clue into that to make sure I give the right answer. So I've got 3 square root of 27 and I've got 2.89. So I know that this is a perfect cube because it is 3. 3 times 3 times 3 is 27. And I know that this is 2.89. So if I'm comparing these as decimals, $3 is more than 2.89.